Hi, I'm Lauren.
Hi, I'm Nikki, and today we'll be teaching you about stoichiometry.
The two types of problems we will be doing today are mass to liters and mass to particles. To do these problems, you will need a periodic table, which will be used to find the molar masses of each element.
And you'll need a mole map to guide you on where to divide or multiply for each unit.
And also, you will need a calculator to help you solve the problem. To start our stoichiometry video, we will be showing you a problem from mass to volume. The mass will start in grams and it will end in liters.
The ratio of the number of particles of an element that reacts with another element to form a product is the same in every reaction, which is also known as particles.
The coefficient in the chemical equation tells us the number of moles. The subscripts also tells us the number of moles. Multiply coefficients times subscripts to determine the number of moles of an element used in a reaction or produced.
Mass is to convert the number of moles given to mass by multiplying molar mass times the number of moles.
To find the volume, you need to convert the number of moles of a gas to the volume of a gas by using the conversion factor of 22.4 liters per 1 mole.
To start off, you're going to want to balance the equation.
To start, you need to put a 4 in front of the HNO3.
Then you'll add a 2 in front of the NO2.
And next, you'll need a 2 in front of the H2O.
Now your equation is balanced.
For this problem, you need to calculate the volume of nitrogen dioxide produced at STP when 9.6 grams of copper is reacted with excess acid.
First, you'll take 9.6 grams of copper, and then you'll divide it by 63.546 grams of copper, which is the atomic mass and which will be your molar mass.
Next, you will need to do a mole-to-mole ratio.
Then you'll take the 2 from the NHO2 and then put into equation divided by 1 mole of copper.
Next, what you will need to do is look at your molar map, and you will see that you will need to multiply by 22.4 liters to get to the volume.
Now you'll put into your equation and multiply by 22.4, which you'll get your final volume of
6.77 liters of NO2. And that was an example of a mass to liter problem. Our next topic is mass to particles.
First, you're going to want to balance the equation.
You will need a 3 in front of the C.
Then you'll add a 2 in front of the CO, and now your equation is balanced.
The problem is, if 104.21 grams of SiC are produced, then how many molecules of SiO2 were reacted? To start out, you will need to take the 104.21 grams of SiC and find the molar mass of it.
Then you'll take your periodic table to find the molar mass of SiC. Si is 28.0855 as its atomic mass, and then C's atomic mass is 12.011. If you add those together, you get 40.0965, which is your molar mass. And this is how it should look so far.
After you find the molar mass, you will then need to find a mole-to-mole ratio. You are going to put the unknown, which is the SiO2 on top, and the known of SiC on the bottom.
Both of their ratios will be 1 because in the equation they balanced out with only 1 mole, and then that's how your equation should look like.
The mole map is going to be needed again, and you will then see that you will need to go from moles to particles. To do that, you will need to multiply by Avogadro's number, which is 6.02 times 10 to the 23rd.
After you put it all together, your equation should look like this before you get your answer. Your answer should come out to 1.564 times 10 to the 24th molecules of SiO2. To recap how to solve an equation by mass to liters, you'll first start with the given mass, and then divide by the molar mass. And then you'll multiply by the mole-to-mole ratio in the given balanced equation. Then lastly, you'll multiply by 22.4 liters to get your final answer.
To review on how to do a mass to particle problem, the steps are very similar to a mass to liter problem. First, you will need to start off with the given grams. Then you will need to divide also by the molar mass. Then you will need to multiply by the mole-to-mole ratio. which was given in the problem above. Then you will need to multiply by 6.02 times 10 to the 23rd, which is also known as Avogadro's number. Then, once you multiply that all out, you will get your given answer.
Thank you for watching our video.
We hope you enjoyed it!